In the heart of one of the world's driest deserts, something extraordinary is happening. Dubai is making it rain, not just predicting weather, but controlling it. Using science straight out of science fiction, this futuristic city is turning clouds into rain factories, flying planes and drones into the sky to trigger downpours on command. From barren sands to blossoming greenery, Dubai's mission to conquer its harsh climate is rewriting the rules of what's possible. But how exactly do they do it and why? Get ready to uncover the hidden system powering Dubai's artificial rain. This isn't magic, it's engineering. From parched sands to visionary dreams. In the blistering heat of the Arabian desert, where temperatures soar above 45 degrees and rain is a rare visitor, Dubai rises like a shimmering mirage. A city built against all odds. Steel skyscrapers stretch into the sky, man-made islands dot the coast, and every luxury seems within reach. But beneath this modern marvel lies a pressing, unglamorous challenge: water. Dubai is dry, not just seasonally, but fundamentally. The region receives only a few inches of rain each year. With a rapidly growing population and expanding industries, from tourism to agriculture, the demand for water has only intensified. This desert city, home to over 3 million people, relies heavily on desalination plants that convert seawater into drinkable water. While effective, this method is energy-intensive and costly, and it's not enough to guarantee a secure future. Faced with this challenge, Dubai's leadership didn't flinch. Instead, they leaned into their reputation for thinking big. If nature wouldn't provide, why not make it happen? What if the skies over Dubai could be made to rain on command? This wasn't just a pipe dream. It was the beginning of something extraordinary. An idea that started as an ambitious solution quickly evolved into a full-scale technological pursuit. The plan? To create rain artificially through a process known as cloud seeding. It was time to take control of the weather, to turn arid skies into a sustainable source of life. As the city reached higher, so did its vision for green parks, fresh water, and a future not limited by nature's boundaries. Why cloud seeding? For a city surrounded by sea, it might seem odd that water is such a scarce resource. But the truth is, Dubai can't rely on natural rainfall or freshwater lakes. They simply don't exist here. And while desalination helps, it comes with a heavy environmental and financial price tag. That's why cloud seeding caught the attention of Dubai's innovators. This is a method where tiny particles are released into clouds to encourage them to produce rain. It sounds like science fiction, but it's based on real, decades-old science that's been used in places like the US, China, and Australia. In the early 2000s, Dubai started exploring whether this method could be adapted to its unique desert conditions. The idea was simple, but powerful. If you can't wait for rain, why not make it? What made this more than just an experiment was Dubai's commitment. Instead of running a few small tests, the city poured resources into building a full infrastructure. Planes, equipment, meteorologists, and cutting-edge tech, all working together to change the weather. This wasn't about chasing clouds randomly. It was about understanding them, manipulating them, and using every bit of scientific knowledge available to bring rain to one of the driest places on Earth. So began a journey that would blur the line between nature and technology and raise the exciting question: could humans really control the weather? What makes rain happen naturally? To understand how Dubai creates artificial rain, we first need to understand how natural rain works. It all starts with clouds. When warm air rises into the sky, it cools down. This cooling causes moisture in the air to condense around tiny particles like dust or pollen, forming small water droplets. As more and more droplets stick together, they grow heavier, eventually falling to the ground as rain. But here's the problem in a place like Dubai. There's not enough moisture in the air, and the conditions for natural condensation rarely line up. The clouds that do form often stay dry or disperse before they can produce rain. That's why cloud seeding makes sense here. It gives nature a little nudge. Instead of waiting for the perfect storm, scientists step in to help clouds do what they can't do alone. It's like giving them the building blocks they're missing. This approach doesn't create clouds out of thin air. It works with what's already there. And by boosting the natural process, it becomes possible to turn a dry sky into a rain cloud with just a bit of help from science. How seeding works. Now that we know how rain happens naturally, let's talk about how Dubai makes it happen on purpose. The key lies in a process called nucleation. Think of it like this. In order for water droplets to form in a cloud, they need a tiny surface to cling to. In nature, this might be dust or salt particles. In cloud seeding, scientists introduce man-made particles like silver iodide or potassium iodide into the cloud. These materials are specially chosen because they attract moisture. Once released into the sky, these particles act as nuclei, tiny anchors around which water vapor condenses. As more vapor gathers, small droplets begin to form. These droplets collide and combine, growing heavier and heavier until gravity pulls them down as rain. It's a chain reaction, carefully timed and meticulously controlled. But none of it works without one crucial thing: getting those particles into the clouds at the right place and the right time. And that's where technology comes into play. So how does Dubai pull off this delicate operation? The next chapter reveals the first boots, or rather nozzles, on the ground at Batno. Ground-based generators. Not all of Dubai's cloud seeding magic happens in the air. In fact, some of it begins right on the ground. Across the region, you'll find discrete stations equipped with devices that shoot cloud seeding particles straight into the atmosphere. These are called ground-based generators. They look like small towers or launchers, often placed on higher terrain to maximize reach. When meteorologists predict favorable cloud conditions, these stations are activated. They release fine particles of silver iodide into the rising air, where natural wind currents carry them upward into developing clouds. Each launch is coordinated with real-time weather data, humidity levels, wind direction, and cloud movement. This timing is critical. If it's too dry or the clouds aren't dense enough, the effort won't work. But when the stars align, when the sky is just humid enough and the winds are in your favor, those tiny particles can spark the chain that ends with rain falling over the desert. These ground units don't work alone. They are part of a bigger system complementing aerial efforts. Together, they form a two-pronged approach to seeding clouds from both above and below. And speaking of above, next we follow the planes that fly straight into the clouds to finish what the ground team starts. Plane-based seeding. While ground generators play their part, much of Dubai's artificial rain is born in the sky, carried out by a fleet of specially equipped aircraft that fly straight into the clouds. These aren't just any planes. They're modified to perform one job with pinpoint precision: seed the skies. Inside the aircraft, there's a highly coordinated setup. Tanks of silver iodide are connected to dispensers fitted along the wings or inside the fuselage. When the plane reaches a cloud that meets the criteria, sufficient moisture, the right altitude, and temperature, the pilots activate the system, releasing the particles directly into the cloud mass. But these missions aren't flown blindly. Every flight is guided by a real-time stream of satellite imagery, radar data, and atmospheric analysis fed directly to the pilots and ground controllers. It's a highly choreographed dance between human expertise and meteorological technology. Pilots often work side by side with trained meteorologists to ensure the best possible outcomes. The altitude advantage of these planes makes a big difference. They can reach higher-level clouds that ground generators simply can't access. This allows Dubai to tap into cloud systems forming miles above the desert, expanding the potential rain zones. Precision is everything. Everything: the timing of the release, the speed of the aircraft, and even the angle at which the particles are deployed, all are calibrated to maximize efficiency. In this way, seeding becomes more than a process. It becomes a mission, flown with the intent to make nature yield a rare and precious resource. As impressive as these aircraft are, they're not the only ones navigating the skies. A new wave of technology is emerging, unmanned, efficient, and remarkably intelligent. The next chapter belongs to the drones. UAVs take to the skies. In the quiet hum of the desert skies, a new force is rising. Drones, those sleek, silent, unmanned aerial vehicles, have begun to transform the way Dubai seeds its clouds. Compact, agile, and cost-effective, these flying machines are reshaping the rules of weather modification. Unlike planes, drones can be launched quickly and maneuvered with extreme precision. They're particularly useful for reaching small, localized cloud systems that might not justify a full aircraft deployment. Equipped with miniature seeding, canisters, and guided by real-time weather data, drones can climb to optimal altitudes, release their payloads, and return, sometimes all in a single pre-programmed loop. The flexibility they offer is invaluable. In remote or mountainous areas where building ground stations isn't feasible, drones bridge the gap. They can fly where planes can't and do it with minimal human oversight. And since they run on electric or hybrid power, they're also more environmentally friendly, a critical factor in a system designed to promote sustainability. But these UAVs don't just carry cloud seeding material. They're eyes in the sky, constantly gathering weather data, monitoring atmospheric changes, and feeding this information back to control centers. This dual purpose, both action and observation, makes them indispensable in Dubai's weather arsenal. Drones represent the next generation of cloud seeding, faster, smarter, and more adaptable. And as we move into this new era of airborne innovation, there's another key group working behind the scenes, decoding the skies and deciding when it's time to fly. Meteorologists and real-time data. Behind every raindrop that falls over Dubai, there's a team of experts watching the skies. These are the city's meteorologists and data analysts, the unsung heroes of artificial rain. Their job? To track weather patterns, identify promising cloud systems, and determine the perfect moment to begin a seeding operation. Working from high-tech control rooms, these teams analyze an incredible volume of data. Satellite feeds provide global views of cloud movement, while local radar systems measure wind direction, humidity, and cloud density. Sensors placed throughout the region feed real-time updates into powerful weather models that predict whether conditions will support rain. This isn't just about watching weather, it's about anticipating it. Meteorologists look for subtle cues, rising air temperatures, shifts in wind currents, the vertical structure of clouds, to make split-second decisions. Once a potential rain event is identified, they notify the aircraft teams, drone operators, or ground station crews to get ready. The entire operation depends on this real-time feedback loop. Timing is critical. Seed too early and the clouds won't be ready. Too late and the opportunity is gone. That's why Dubai's weather teams work around the clock, constantly monitoring and adjusting. It's a high-pressure job, but one filled with excitement. Every successful rain event begins with their call, and when clouds are seeded and rain begins to fall, it's a direct result of their vigilance. Of course, all this effort hinges on more than just science. It also depends on the sky itself. Because no matter how prepared you are, nature still has the final word. Next, we dive into that delicate balancing act between technology and weather. Timing, wind, and atmospheric ballet. Creating artificial rain is more than a technical feat. It's an art form, one that relies on the perfect alignment of natural forces. Think of it as a kind of atmospheric ballet. The clouds, the wind, the moisture in the air, they all have to perform their roles in harmony. Otherwise, the show doesn't go on. Clouds themselves are complex. They can look full and ready from the ground, but high above, their internal structure may not support rain. That's why every potential cloud system is carefully analyzed. Meteorologists look at size, shape, and altitude. Some clouds are too thin, others move too fast. And if the winds aren't blowing in the right direction, any seeded material may drift far from the target zone. Wind plays a huge part in this dance. It can lift, spread, or completely scatter seeded particles. Dubai's teams must anticipate these movements to ensure the particles reach the ideal part of the cloud, what they call the sweet spot. Even humidity levels have to be just right. If it's too dry, the droplets will evaporate before they ever reach the ground. This is why every mission is a carefully timed operation. Once everything aligns, the teams move fast, deploying planes, activating ground stations, or launching drones. Then it's a waiting game, watching for the telltale signs, thickening clouds, cooler air, and finally those first soft drops on the hot sand. It's not always successful. Sometimes the conditions change at the last moment. But when it works, it's like conducting an invisible orchestra, every part in tune. And the result, a rainstorm in the middle of a desert. And when those first drops fall, the impact is both emotional and practical. Because in a place like Dubai, every drop counts. So how do they measure success? That's where we go next. Measuring success. When the rain finally arrives in Dubai, it's more than just a refreshing break. From the heat, it's proof that the entire system, technology, science, human decision-making has worked. But beyond the visual impact, How do we know that cloud seeding is actually making a difference? Success here is measured in data. After each seeding operation, ground sensors, weather stations, and satellite tools measure the amount of rainfall that occurred. Even small increases, just a few extra millimeters, can be considered a major win in a region that gets so little rain to begin with. Reports are generated after each mission. They compare rainfall levels in seeded clouds to nearby unseeded ones. Scientists also track changes in local reservoir levels and water table depth over time. In many cases, the results are clear. Seeded clouds consistently produce more rain than those left alone. But the proof isn't just in the numbers. Farmers in the region report greener fields. Water authorities note increased reserves. And everyday people notice something new: lush parks, revived landscapes, and a cooling break in an otherwise unrelenting climate. These early successes built confidence. What began as a series of tests evolved into a full-scale program with real, measurable impact. And as the evidence grew, so did the ambition. Because when you can make it rain on command, the next logical step is to scale it up, to go from experimental drops to transforming entire landscapes. And that's exactly what Dubai set out to do. From pilot to oasis. What started as a scientific experiment quickly evolved into a national strategy. After the initial cloud seeding trials proved successful, Dubai wasted no time in expanding the program. The early missions had shown it could work. Now it was time to take things to the next level. The city began investing heavily. More aircraft were added to the seeding fleet. Ground-based generators were installed across strategic locations in the Emirates. Drone technology was rapidly upgraded, with newer models designed to fly farther, higher, and seed more clouds per mission. And perhaps most importantly, the entire operation was integrated into Dubai's broader water management strategy. This wasn't just about creating rain for the sake of science anymore. It was about reshaping the landscape and supporting sustainable growth. The artificial rain helped to recharge underground aquifers, fill reservoirs, and water green spaces. Parks, gardens, and golf courses that once depended solely on desalinated water could now be supported, at least in part, by rain from the sky. In agricultural zones, farmers began to notice healthier crops and more consistent soil moisture. Even the city's famously lush urban areas started to look more vibrant. Slowly but surely, the dream of turning desert into oasis was becoming a reality. This visible transformation made one thing clear: artificial rain wasn't just working, it was making a difference. But with every success came new questions. Could this be done everywhere? And more importantly, was there a cost to all this progress? As the program grew, so did the scrutiny. Ethical and environmental concerns. As Dubai's artificial rain program gained global attention, it also drew its share of skeptics. Questions began to surface, not just about how the process worked, but about its long-term effects. Could messing with the weather have consequences we didn't fully understand? One of the biggest concerns was environmental. Silver iodide, while effective, is still a foreign substance being introduced into the atmosphere. Critics wondered what would happen if too much of it accumulated in the soil or water. Would it affect ecosystems? Could it enter the food chain? Then there were the ethical questions. If one region makes it rain, does it take moisture away from another? In a system as interconnected as Earth's atmosphere, could shifting rain patterns in Dubai disrupt weather elsewhere? Dubai didn't ignore these concerns. In fact, the government invested in comprehensive environmental impact studies and began working with international experts to monitor long-term effects. So far, no major negative consequences have been observed, but the research continues. Transparency became a key part of the program. The public was informed about when and where seeding would happen. Experts were invited to share findings and voice concerns. Dubai knew that if this technology was going to lead the way, it had to be done responsibly. Still, the debate remains active. And as the city looks toward the future, there's a clear understanding that innovation must walk hand in hand with caution. Refining the process. While Dubai's current cloud seeding methods are impressive, they're far from the final version. This is a program that evolves with every new piece of data, every mission flown, and every drop of rain measured. The goal is constant refinement, making each seeding operation more effective, more efficient, and more environmentally safe. Researchers in the UAE and abroad are exploring new seeding agents that could work better or have less environmental impact. Some are even looking into biodegradable particles that disappear harmlessly after doing their job. The The search for alternatives to silver iodide continues with hopes of finding a solution that's just as effective but even cleaner. Meanwhile, drone technology is advancing rapidly. Engineers are working on swarms of smaller, AI-powered drones that can operate autonomously. These machines could detect ideal cloud conditions on their own, navigate to the right altitude, and deliver their payload with almost no human input. There's also growing interest in using artificial intelligence to predict the best times and places to seed. By analyzing years of weather data, AI models can identify patterns that humans might miss, maximizing the chances of success with fewer resources. Dubai isn't doing this alone. The city is collaborating with international meteorological agencies, universities, and climate scientists to stay on the cutting edge. Conferences are held, papers are published, and field trials are run constantly. What started as a bold idea is now a living, breathing research project, one that continues to push the boundaries of what's possible in weather control. A model for water-stressed regions. Dubai's cloud seeding success story has turned heads around the world. For countries and regions facing similar water shortages, the program offers something more valuable than rain. It offers hope. From the deserts of Saudi Arabia to the dry lands of Western Australia and the Indian state of Rajasthan, governments are now exploring their own artificial rain initiatives. Some are partnering with the UAE to study its technology and adopt its methods. Others are developing parallel strategies inspired by Dubai's model but tailored to local conditions. This global interest has raised a new question. Could cloud seeding become part of a global water solution? The answer is promising, but complex. Each region has its own climate, challenges, and ethical concerns. What works in the UAE might not work the same way in North Africa or Central Asia. But the idea, the ambition to create water where there is none, is spreading. Dubai has taken on a new role in this conversation. It's not just a city using cloud seeding for its own benefit. It's now a case study, a leader, and a potential teacher in how to responsibly manipulate weather. Of course, global cooperation will be key. Sharing data, establishing guidelines, and ensuring environmental safety will matter more than ever. But if done right, artificial rain could be one of the tools humanity uses to adapt to a changing climate. And as other nations begin to dream bigger, Dubai continues looking ahead. Rain on demand and beyond. As the world faces increasing water stress and unpredictable climate patterns, Dubai's artificial rain program offers a glimpse into a possible future. One where technology doesn't just adapt to nature, but partners with it. Imagine cities where rainfall is managed like electricity, scheduled, measured, and distributed where needed most. Imagine desert regions with green belts, sustainable farms, and cooling microclimates. That vision is no longer fantasy. It's being prototyped in Dubai right now. But this isn't just about rain. Dubai is integrating its cloud seeding efforts with other advanced water systems, like desalination and water recycling, to build a complete, resilient water strategy. And it's thinking long-term about how weather management might be used to cool urban areas, protect crops from drought, or even restore endangered ecosystems. Of course, the future won't be without challenges. Climate change is altering the rules of weather, making clouds less predictable and atmospheric models harder to trust. But with AI, automation, and scientific cooperation, the tools to keep adapting are already in motion. At the end of the day, Dubai's artificial rain is more than just a scientific achievement. It's a symbol, a signal that even in the harshest environments, with the right vision and determination, humanity can find ways to not just survive, but thrive. And so, as raindrops fall over the desert, turning dust to life, one thing becomes clear. This isn't just about weather. It's about what we choose to make possible. From dust storms to rainfall, Dubai's journey proves that innovation can bloom even in the harshest climates. As skies open and deserts green, this bold experiment may become a global solution. Could controlled rain reshape our world? One thing's certain, Dubai isn't just changing the weather, it's changing the future.